Hey Algebra 1, here are your notes for 12.5 with dividing polynomials by monomials and binomials. And we've already talked a lot about each of these, but today we're going to take it one step further. So, one way to divide a polynomial by a monomial is to divide each term of the poly by the mono. A second, less common possibility would be to factor the numerator and just simplify anything outside of the parentheses with what's on the bottom. Now, the cool thing about this is we've already actually been doing both of these things. You may just not have realized it. So let's jump in and then we'll discuss when each method actually applies through those examples. So this first one says find 4r squared minus 12r divided by 2r. And another way of writing that same idea is shown there. 4r squared minus 12r divided by 2r. Now we know when two things have a common denominator, you can add their numerators and put them over the same thing. So a really good example of this would be something like 1/4 plus 2/4. If I'm going to add something, another way to rewrite this would be 1 plus 2 over 4. And then obviously we would simplify that to 3. But what we're going to do, and the reason I showed you this example, is because not only can we add things in the numerator, we can break them apart too. So right now you've got two things on top over a single denominator. But what I'm going to suggest is that in order to divide this, we break it up. We say 4r squared over 2r minus, I'm taking that symbol from the top, minus 12r divided by 2r. So I've gone from this backwards into two parts. We know how to divide monomials by monomials, so that's what we're going to do. 4r squared divided by 2r becomes 4 divided by 2 is 2 over 1, and r squared over r, notice one of those r's is going to cancel. I guess I'll simplify this too. So I get 2r over 1 if you want to write that. And then if I simplify my second, I'm going to get 12r divided by 2r. r divided by r is 1, so that reduces. 12 divided by 2 is 6 over 1. So I'm left with 6. And then I just bring down the sign in the middle. I've now divided this polynomial by this monomial and gotten the answer 2r minus 6. Simply by breaking up that fraction. And that's all we're going to be doing. The only difference is we may have to add more terms. So let's look at the next example and see what that looks like. Notice this one gives us a problem, but it has 3 distinct terms on top. The only difference here is that instead of having 2 separate fractions to work with, we now have 3. So let's go ahead and write those out. We've got 3x squared divided by 4x. We have minus, because I'm taking that symbol, 8x over 4x plus 4 over 4x. Now, I caution you, when you have this many, it's going to be easy to try and say, well, once I reduce them, I can put them all back together. But that may not be the case if the denominator ends up changing. So let's see what that means. In this case, I've got 3/4. A single x cancels out here. It's really hard to cross out an x. So in this case, I'm left with 3x over 4. In the second one, the x's both cancel, and 8 over 4 just becomes 2. In the last one, the 4's reduce, and I'm left with a 1 on top, so I get plus 1 over x. Now, you may be really tempted to go, all right, 3x minus 2 plus 1 all over 4 minus x or something like that. Don't do that. We don't like that. We only reattach things. We only put things back together if they have the same denominator. If they don't, we are out of luck, and we have to circle that as our answer. You can only simplify so far. It's not always possible to take it one step further. So let's look at some more examples. If you're already feeling confident, go ahead, pause the video, try these on your own. but otherwise let's just work through some more together. I've got 3 terms here, which means I have 3 fractions to reduce. X cubed over x plus 2x squared over x minus x over x. And now we reduce. X cubed over x becomes x squared. Boom. Just that simple. 2x squared over x, that only cancels out one of those, and it doesn't do anything to the 2. So plus 2x. Those are technically both over 1. And then minus x over x. Hey, that doesn't cancel. I know a lot of you are like, oh yeah, it cancels out and there's no more fraction. Nope, pause. This is why I don't like the word cancel sometimes. It's in my vocabulary a lot. But what's technically happening is when you have x divided by x, it's turning into 1 over 1, or just 1. So this is technically minus 1. If you start off with 3 fractions, you must end with 3 terms. Don't get lazy on me. All right, just like I said before, this one turned out really nice because it didn't end with any fractions. But if it did, remember you can only recombine them if they have the same denominator. All right, let's go again. 10a squared b over 2a plus 12ab over 2a minus 8b over 2a. Simplify. These arrows are not necessary. I just like drawing arrows. That's gone. So this becomes 5ab, no fraction. I just reduced that. These cancel. Those reduce to 6b. And this last one, you can only reduce the numbers really, so it's going to be minus, I just had a brain fart there, 4b minus, yeah, there we go, just like that. And there you go. I could multiply this entire thing by a to get that last term to be a non-fraction, but unless you're really confident with how to do that because you've seen it somewhere else, I would just leave it like this. You can't really simplify it any further. All right. Yeah, there's more on the back. That's what I thought. Last one on this page anyway. All right, this one, I'm not going to break it down into the fractions, even though there's 4. I don't really want to rewrite them. All I'm going to do is break them up kind of in my mind. So 2a cubed b cubed over 2a squared b squared. The 2's become a 1. I'm left with an a and a b in the first term. So the division of this first term by the denominator is ab. Same thing here. I'm going to say that's 8 divided by 2 is 4. It's positive 4 plus 4. A squared over a squared cancels. B squared over b squared cancels. So that's just 4. That's all you really get there. Negative 10ab over that becomes negative, and this one's going to be a fraction, so 5a over a squared becomes a on the bottom, b over b squared becomes b on the bottom, and then plus 12 divided by 2a. It only reduces the number. So 12 over 2 becomes 6. None of the a's or the b's cancel, so that is what we're left with. Again, if you need to use these methods, please go ahead and do so. I just want to show you it can be done. And also, because I'm a bit of a perfectionist, I'm going to rewrite that so it looks a little bit nicer. There we go. That is what I would leave as my final answer because it cannot be simplified any further. All right, well, let's check out the backside. Dividing polynomials by binomials. To divide a polynomial by a binomial, factor the numerator, and if the factor matches in the numerator and denominator with the divisor, you can cancel or simplify. If this sounds familiar, even with all that math language, it's because we've been doing it since the first section. So just like I've shown you in some of the multiplication and division videos. If we're going to divide this, the first thing we need to do is factor that top into its smaller parts so we can see what cancels or what reduces. So the top, in this case, is going to be x. It's going to be a 5 and a 2. They're both going to be positive, and it's all going to be over x plus 2. And then we're just doing the same thing from the other videos. If you've got an x plus 2 on a top and an x plus 2 on the bottom, guess what? They reduce because x plus 2 divided by x plus 2 is just 1. It's just a big fancy 1 hidden in there. And our final answer is x plus 5. Technically over 1, but I don't need to write that. I don't feel like I need to go through a ton of these with you. In fact, I want you to pause the video right now, go through them all on your own as you've seen them in the other videos. Should be pretty confident with these. Once you've done that, come on back and you can double check. All right, hopefully, you paused the video long enough to try these on your own. Let's go through them. I'm going to start off by rewriting this as a fraction. It's my personal preference. You don't have to. Divided by b minus 2. Let's simplify that top. Factoring is sometimes tricky. I've either got a 6 and a 1 or a 2 and a 3. The only way to get a positive number with that negative in the middle is to make both of them negative, and to make 1 a 2 and 1 a 3. Boom. The reason I like doing these so much is that because most of the time if you factor something wrong, nothing will cancel. And it's pretty indicative that you have to go back and make sure you factored correctly. So if I got here and say this was a plus 2 and nothing canceled, I would know to double check myself and to double check how I factored that, because something should cancel out most of the time here when we're doing these problems. But I factored correctly. I know this because b minus 2 and b minus 2 cross reduce there, and I'm left with my answer of b minus 3, just like that. All right, next one. I'm gonna simplify it down here. You can definitely tell at this point why I wanted to make sure you were all so fluent in factoring, because man, it is gonna keep coming back. 16 and 10, the only way to get that is an 8 and a 2. Quick check, it's probably gonna be a negative, because that would mean that those cancel, but I cannot assume that. It is very possible in math, you all know math is tricky, that this is a positive and that this problem is set there to trick me, to make me think that they cancel even if they maybe don't. Those problems do exist. But in this case, it is not this problem because both of them are negative. Negative 2 times negative 8 is positive 16. Negative 2 plus negative 8 is negative 10. These do cancel. And my final answer is x minus 2. But just keep an eye out. Just saying. Ooh, tricky one. I know how much we love factoring with a number in front. Get that handy-dandy X puzzle method back out. I'm not going to use it. We should know that stuff by now. Taking the training wheels off, boys and girls, because you are all very capable. I put it over y plus 2. This top part, 2y, this is y. The only way to get a 2 there is a 2 and a 1. The only way to get a 5 in the middle is to make both of those positive. Now my y plus 2's do in fact reduce. That becomes a 1, so 2y plus 1 times 1 is 2y plus 1. Look at these. These are awesome. Look at how nasty they start out and how amazing they end. Isn't this awesome? Math is so cool. I love it. If you have any questions, let me know.